Okay, now let's see if we get any viewers. Good morning. So we're going to try lecture this way. I have nobody watching right now, so I'm super excited. And in true Dr. Choi form, I am on time. So I'm hoping everybody got the new link. I'm sorry I goofed on the question and answer part. So what you can do if you're watching is type in your questions on the side. So we're going to wait for a few more people to join. And then what I'm going to do is start going over the worksheets that I texted or emailed to you last night. So the first one we're going to do is it's called the buffers and barf table one. And again, it's just a little review for what we did from last week. And then after that, we're going to try to do a new formula called Henderson-Hasselbalch. Okay. So let's get started. So again, if you can kind of go back and remember what a buffer is, it's a blank. Can anybody remember what that blank is? All right, it's a solution. That's right. A solution is a mixture. So remember, you got to have two things. All right. So will somebody, just to test out the Q&A, can anybody go ahead in the question section over to the right, type in what are the two things that you would have in a buffer? If anybody's able to do that for me, that'd be great. And let's just try this out and see. So what are the two things that you would find in a buffer? So hopefully somebody will type that in soon. I see 5 people watching. Yes, 5 out of 24. That's awesome. Okay, we've got a 20%. Is anybody typing, hopefully? Okay, no one's typing. Nope. Okay. All right, well, I'm going to go ahead and answer it so that way we can move along. But the two things you need in a buffer are a weak acid and its conjugate base. And we kind of talked about that on Friday, right? A conjugate base is the leftover, right? It's the part of the acid after you take away the H, what does it look like? So if we can see the board over here, I'll bring this closer so you guys can see. So for example, if we have H, oh, that's not good. So if we have something like H, C2H3O2, right? So, oh, it looks backwards on your screen. Huh. Can anybody type in and tell me if it looks backwards when you guys look at it? Let's see. Okay, so we answer that. You can type, but I have no answer. Oh, okay. Well, that's good, Winter. Thank you. No, not pH. Nope. Okay. Winter's here. Joshua's here. Great. All right. Can anybody type in the question? Do you guys see this backwards? Or do you guys see this forwards? I see it on my screen as backwards. I don't know why. That is weird. Okay. Well, anyway. So, but let's just say this is my acid. Now, how do I know if it's a weak or strong? You know it's a strong if it's one of the 6. And I'm going to not go over that with you, but those are the 6 you need to memorize. So it's not one of the 6, you know this is weak. So this looks weak. It's not one of the 6. So what's the conjugate base? Well, you just cover up the H, and that's what it looks like. But remember, once you take off an H, it's going to be negative. Okay? So it'll be C2H3O2 minus. Okay, so that's the leftover, right? After you take off the H, that's leftover. Okay, good. It's not backwards. Right on. Okay, so a buffer has a weak acid and a conjugate base. Okay, has to match. The other thing you can do is also a weak base. So here's a very fine example of a weak base. Now, ALOH3. Now you're probably thinking, oh my gosh, Dr. Joy, there's no H. It must be a base. Remember, it has to be group 1 and group 2 to be a strong base. So if it's group 3, it's not a strong base, it's considered weak. Right? So what would this be? This would be a weak base and its conjugate acid. So the way this would look like, and I know this looks a little weird, you would add on an extra H and it would be a plus sign. Okay, so if you had a base buffer, this would be a base buffer, then you would have a weak base and its conjugate acid. And the conjugate acid has an extra H versus a conjugate base has the H taken off. Okay, good. So we've gone over buffers. It's a little review. So if you could pull up the worksheet called base and buffers, or buffers and barf table. So let me grab that real quick. All right. It looks something like so. Okay. So if you guys can see it, it looks like this. All right. Buffers and barf tables. So if you guys have that with you, all right, let's go over one of these problems together. All right. So I'm going to answer all these. It looks forward. Thank you. Looks normal. Great. Okay. Fergie's here. Good morning, Fergie. Good to see you. Autumn. Hi. Oh, Cameron. This must be up your alley. We're doing iTech. Woohoo! Oh my gosh. Okay. So let's go ahead and do the first one. So which one of these is a buffer? All right. So go ahead and figure out which ones are. Go ahead and type your answers in the question section so we'll know who got the right answer and who didn't. And if it is a buffer, you're going to go ahead and write the equation for it. All right. So let's do A. Is A buffer? Is A buffer? So it says KF and HF. Hey, Trey, good to see you. Okay. So, is that a buffer, KF and HF? Well, Now you're going to read it from left to right. So actually, this is actually, KF is actually really F minus. What? Dr. Choi, you can't just drop the K. Yes, you can. Remember we talked about how in chemistry RS, you can't buy F minus. You can't go to the store and just buy F minus. So we have to package it. Remember, your shoes come with a shoe box. So really, this is what we call, you guys remember what's called? Starts with an S, ends with spectator ion. Yeah, it's an ion that just hangs around. So this K is just here for just fun. So really, it's an F minus on letter A. So what we have here is we have an F minus, okay, and we add it to water, right? We're always adding water. Don't forget to get me my phases. And again, I'm not normally picky about details, but with phases you are because we get rid of solids and liquids. That's right. So we always have to make sure we write that down. Now this is weak, so we're going to go ahead and write 2 arrows. When do we only have 1 arrow? That's right. When you have a strong acid or a strong base. So in this case, this is weak, so we can put the 2 arrows. All right, here we go. And notice this guy is going to turn into a what? The next thing across the slash is an HF. So here, it's going to turn into an HF. Grab that H from that pour water, and the water will become an OH minus. This is aqueous, and that should be the equation you should have written for A. Now, is this a buffer? All right. Ladies and gentlemen, we have here, this is a little weird, a base. This guy is attacking. He's busting. He's grabbing an H. He's bullying. So this is actually going to be a weak base. Dr. Choi? Yes. How do you know that's a weak base? Well, is it group 1 or group 2 on the periodic table? And does it have an OH? No. So it must be a weak base. But how does he know it was a base? We'll take a look. He went from no H's to 1 H. Must have busted somebody. So that's why I knew it was a weak base. Now, what's water acting over here? Well, if you got a buster, you have to have a victim. Ladies and gentlemen, this is your answer. Okay. So you have a weak base. So this guy must be what? I'll give you a hint. Starts with the word conjugate. That's right. This one would be a conjugate acid. We have a weak base and it's conjugate acid? Yes. So letter A, guys, is a little tricky, but it's actually a base buffer. All right, how do we feel so far? 15 people, right on. Okay, cool. We got like, let's see, how many more do we need to do? 9? 9 more people up full class. Woo! All right. So the cool thing about this video is it's actually recorded for posterity. So if you overslept or you're doing something nefarious and not in class right now, you can actually watch this later on. Okay, so what we're going to do now, I'm going to clear off some of these questions here. Alrighty. And, all right, any questions so far? You don't have to answer, but any questions about A? Any questions about A? All right, so let's look at B and C and D real fast, and we're going to move on to some other stuff. Oh, you're feeling good, Josh. Great. Okay, what is this thing? It is a base buffer. Yes, Winter, this is a base buffer. And the reason why is because in this equation, this guy right here, F minus, which is what the problem says. It says KF. Remember, the K is the spectator ion. So we're not going to pretend that really KF means F minus. And of course, anything you have, you always write it in water. That's what we've been doing for the last several weeks. So when you write it in water, it becomes an HF. That's what the next word says in the slash. So this is acting as a base buffer. Yes, ma'am. Okay. If there are any other questions, just post them up here, and I will answer them as they come up. Okay. Trey says, yay. Good. I'm glad. I hope you guys are all wearing, well, I can't see you, so you could be completely naked right now, and I have no idea. So I'm not even going to think that because that's just disturbing to me. Okay. So B, here we go. B. You got an NH3. Not sure what that is. But the next thing is NH4BR. And BR, if I remember, is one of those ions that just sort of goes away. Well, I bet you it's a spectator. Okay, let's check it out. All right, so what do you think NH4BR really is? Well, in water, that BR doesn't really do anything. So it actually is the same as NH4 plus. Okay, so let's check it out. So the first thing we have is NH3. So let's put NH3. And of course, it's always aqueous. And we're going to put it in, oh, let me guess, it starts with a W, ends with otter. That's right, we're going to put it in some water. So H2O liquid. All right. Doesn't look strong to me. Doesn't look like one of the 6 I know, or one of the group 1, group 2 OHs. I'll tell you right now, this is probably a weak. Now, I don't know what weak it is, but it turns into NH4. So you have 3 dialytes here, and you go to 4 dialytes here. So what do you think NH3 did? Do you think NH3 busted and attacked, or do you think NH3 was a victim? Go ahead and put your answer over there on the Q&A. What do you think happened? And if somebody else puts the same answer as you, you don't have to type one in. So can anybody type in what they think NH3 is doing? Being a buster base or being a victim acid? Wow, this is a really slow lag time. Okay, so I'm going to go ahead and say the answer because nobody's typing anything. Winter, almost. It's NH4. There's no okay, you wrote the answer. Oh, good job, Winter. Yep. So we got NH4 plus and OH minus. Yeah. Yay, you got it. Yay. So Buster, that's right, Fergie. So this is a weak base. Absolutely. It went from 3 to 4, and that is your balanced equation. Yay. So, ladies and gentlemen, is this a buffer? Do we have a weak base? Bing. Do we have its conjugate acid? Bing. So, ladies and gentlemen, this is a buffer. Weird looking, but is a base buffer. Right on. What about C? What about C? This one should be out of the ballpark, my friend. This one, you shouldn't even have to write anything. What do you think about C? Thumbs up or thumbs down? So somebody type on there, yes buffer or not a buffer. Wait for somebody to type that in. Anybody? Okay. Nobody's answering, so we're going to go with it is not a buffer. C is not a buffer because HNO3 is a strong acid. It's 1 to 6. You had to. Oh, Josh, it's not a buffer. Careful. Look, HNO3 is one of the strong acids. Oh, it's a strong acid. So if it's strong, it cannot be in a buffer. Think about buff as something soft, like a bunny rabbit. You know, it's got nice, buffy. Well, I guess you can't say Buffy the Vampire Slayer, but you know, nice, soft fur. Buffers help keep you from having an accident. Remember we talked about in lab last week. You have a 3-car distance in front of you as a buffer zone. It's to soften things up. So C is not a buffer because you can't have any strong acid or strong base in a buffer. So C is not a buffer. All right, D. I'm going to let you answer that on your own, and we're going to answer that on Friday. We'll let you try that. What do you think D is? Is it an acid? Is it a buffer or not? If it's a buffer, is it a weak acid buffer or a weak base buffer? Okay, we're going to move on to number 2 here. All right, we're going to practice a buffer problem, and we're running out of time, so we got to go a little faster. Now, for number 2, it says, what is the pH? So eventually, we're going to have to find H, right, of a 3-liter solution. It's got 0.24 of something and 0.18 of something else. Now, ladies and gentlemen, I'm going to tell you right now, this is a buffer. Oh, you meant no, Winter. Very good, Winter. Now that you heard my answer. Okay. So Josh said no, and Dimitri said yes. Okay. All right. So let's take a look at number 2. All right. So let's fill it in. All right. So remember, in the ICE table, it's got to be capital M. Now, capital M stands for molarity. That's right. And molarity, capital M, is moles over liters. Ladies and gentlemen, you're going to take those 2 numbers and divide by 3 before you stick it in the ICE table. So let's go ahead and do that real quick. Let me go ahead and get my calculator. All right, I'm going to get my calculator here real quick. And here we go. So we have the ICE table, and I wish I had a projector, and I don't. So I'm going to have to draw this out. So we have ICE table. We have HC2H3O2. By the way, this acid right here, it's an acid. It's a weak acid because it's not one of my 6. It is vinegar. It's called acetic acid. So if you wanted to know what vinegar was on your Friday night, you're trying to pick somebody up, you want to impress them, you could say, hey, did you know HC2H3O2 is vinegar? You might get yourself a date. Yeah. All right. So we've got this, and we've got this. Dr. Joy! Yes? How come there's no water in this table? Well, guys, do we need to write water? Water is a liquid we never included. So in this worksheet, whoever wrote it, the person at the top, he decided, or it's a he decided to take out that column. But if you want to leave that column, that's fine. You just make sure you cross it out. We don't do liquids. All right, so ICE table I, C, and E. Okay, so hopefully you guys did this correctly. And hopefully you wrote this. All right. Now there should be an icon somewhere for applause. So I don't know what applause looks like when you guys do it, but if you click on applause, maybe I'll see something. If anybody wants to try the applause, I'm happy to check that out. I don't see any applause. So I guess the applause does not work. But you're free to applause if you'd like. I don't see any applause. I guess applause doesn't work. Okay. All right. But what about H's? Do we have any H's in there right now? Remember, a buffer only has 2 ingredients at the beginning, so we're going to go ahead and leave that as 0. All right. Same thing as usual. Here we go. Minus X plus X plus X. Okay. And this will be OA minus X. 0 plus X is X. And 0 plus X plus X. Oh, Winter. I don't know if you don't see it. Yeah, I'll figure it out for the next time because we'll probably have to do this method next Wednesday. So, also, if anybody can send this link to Jessica, I don't have her on the class list. So, Winter, I don't know if you have her email. If you can send the link to this Google Hangout to her, at least she can jump on it. All right, so that should be what your ICE table looks like. Hopefully, you guys got that. All right. And we're going to go ahead and do our Ka because we're an acid. And it gives you the Ka, and it's 1.8 times 10 to the negative 5. Woo woo! And we'll do products over reactants. So here are my products divided by the reactants. So here we go. So X times O6 plus X divided by O8 minus X. All right, so hopefully you guys were able to do that. And dun, 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 my K is small, so I can do my shortcut. What does the shortcut say? Thank you, Winter. I appreciate it. Oh, apparently the applause is at the bottom is what Josh said. And Winter helped me out. The green dots with the live feed progression. Oh, Jessica, you're here. Yay. Okay, good to see you. Yeah, I don't see the applause either. But if you want applause, that's good. But I don't know where the applause is. Sorry. I wish I could see it. Be nice to hear something from you guys. But anyway. All right. So shortcut. We get rid of any time we're adding or subtracting x's. All right. Oh, and Jessica, real quick, I am teaching 12-12 this summer. So if you want to take it with me this summer, I'll be around. Hey. Okay. Oh, you found the applause? Okay. Oh, it's a thumbs up? All right. Well, I don't see any thumbs up. Oh, well, maybe I can send the thumbs up to my boss and get a, I don't know, I don't see any thumbs up. I don't hear anything. Huh. Okay. All right. So shortcut those, get the pluses and the minuses. Can you guys see the screen? Hopefully you guys can. All right. So the pluses and minuses are gone. So if you solve for x, all right, solve for x real quick. So 1.8. Yep. -5. Okay. So my x, if I did this correctly, is 2.4 times 10 to the -5. Okay. Now that we found x, what are we gonna do? pH, right? So here we go. pH is negative log of the h. Since the h happens to be x, stick that number in, and you should get a pH of 4.62. All right. So hopefully you guys did that right. That was on your homework. That was due Monday. And the homework that's due next week is going to be off by day because our lecture is off. So it'll be due Tuesday, not Monday. Okay. And they'll be opening tonight. All right. So that's the first part. Yay, we did number 2. Now, what if we have, number 3, a leprechaun? We're going to skip the barf table for today because we're behind. Okay. And yeah, the dots at the bottom of the feed, you click them, but I don't see, when you applaud, I don't see, I shouldn't cuss on this, huh? So I'm not sure what's going, yeah, Frank, you got 4.6, yay, good. All right, yeah, Winter, I don't see, well, you may be applauding, but I don't see anything. So maybe if we play it again, I'll hear some applause. Maybe, so just go ahead and applause if you like it. All right, yep, Frank got the right X, good. And Jessica, yes, you're going to look into it, great. Yeah, thank you, Autumn, for applauding. I appreciate it. I know the love is there. Dimitri, thank you for the thumbs up. Yang, thumbs up, yay. Okay, all right, great. All right, so I think I got everybody's question. So what would be the pH if HCl? So remember from Friday, I was the leprechaun. I'm the leprechaun. I have this strong acid, ha, 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 and I have an H+, and it looks like I have 0.01. Now remember, we got to change that to big M. So before we move on with my little leprechaun thing, let's change for number 3, the O1 to molarity. All right, so we'll write original is 4.62. All right, so that's the original pH. Okay, leave that up there. Okay, so for number 3, we got to change this O1 moles divided by 3 liters. Right, you got to change it to big M. Got to have the big M. All right, so 0.01 divided by 3 is, bam, 0.0033. Big M. All right, so I got 0.0033 leprechauns coming along. Now, who am I going to react with? Am I going to react with the H, C2H2O2? Or am I going to react with the minus over here? Yep, we're going to react with the minus because this is plus, and this is minus, so these will react. So if I react with this, what's going to happen? These guys will flip their cards and move to this side of the room. So this number is going to go what? Up or down. Remember, if I'm going to react with you, you're going to flip your card and move to this side, okay? So you're going to get another coin if you like. And change it. So remember over here, this was an A minus. Okay, remember the A minuses? So if I react with an H, I become what? HA. And then that means I have to go to this side of the room. Okay, everybody see that? So this number is going to go down. Let's use another color. This is going to go down by that much. So take your calculator, subtract that. So if I'm not mistaken, that should be a 5. I can't do math. Come on now, people. 5, 7, no, 5, 6, 7. 6, 7, 5, 6, 7. Does that look good to you? 5, 6, 7, 10. Okay. Can everybody see the green? Hopefully you can see the green. I can see the green on my screen, so hopefully you can. All right, but then if that goes down, what's going to happen to the other side? The other side's going to go up. Right on. Yes. So that should be 0833. Now do the exact same math with the green numbers. All right. I'm going to let you try that on your own. And then Josh, you're going to go down. Great. Cameron, you're good at this. You're right. Okay. So here we go. So do 833 minus x. Do 05 plus x. And do the exact same math down here. And let's see what you get. And then thumbs up me if you get the right answer. Okay. We're going to try this. All right. Times 3. Okay. All right. Okay. So since we're doing this in green, I'll put the new pH. So with HCl added, we get 4.58. All right. Did you guys get that? Let's see. Cameron said would go down. Good call, sir. Calculator. Okay. 0567. Yep, that's right, Calculator. Good. It's going to go down, and that's what Josh got. Okay. So how'd you guys do? Good? Yeah, you guys got 0.58? Does that make sense? That I'm adding acid. If I want to add acid, when it makes sense, the pH would get closer to 0. So yeah, we must have done this right. Okay, let's do the next problem. All right, so let's erase the green. Erase the green. So we're going to go back to the original. Okay, erase the green. We're going to do some red now. You know me, I love my colors. Now, for number 4, what would be the pH if you added 0.01 of NaOH? Oh, so now we're going to add this guy. Strong base. Strong base. So what's going to happen if I add strong base? Am I going to react O minus with a minus? That doesn't make sense, right? So minus to minus isn't going to work. Let me come over here. Okay, what about an H? Ooh, an H would react with that O minus, wouldn't it? And what would happen? So the HA would react with the OH minus, react, and this would flip over and go to this side. So what's going to happen is this number is going to go down. Very good. So instead of 008, this is going to be 0.767. And then this number is not going to be 06. This is going to be 0.633. All right. Do the problem again. And we're going to save some time here. I'm going to let you guys do this on your own. But to give you the answers, you can check yourself, because that's the cool thing about this video. You can review it later. But if you do this correctly later on your own time and you try it, you should get, hold on, Rabbi. Okay. Nope. You should get a new pH. with the NaOH added, you should get 4.66. That kind of makes sense. You're adding base, so it's going to go higher than 4.62. Okay, so, yep, that will go up. So Cameron, here's a really cool trick. And those of you who are iTech majors, is a great trick to remember. Those of you who are not iTech majors, is a great trick to remember too. You guys listening? You guys listening? Here we go. Flash. Here we go. If you add base, the conjugate base will go up. If you add base, the conjugate base will go up, and this will go down. If you add acid, the weak acid will go up, and the base will go down. So that's just a real quick way to kind of remember who's going to go up and go down. If you can't remember, who's going to? What leprechaun are you talking about? Just remember this. If you're adding a strong acid, then that means the H number will go up because you're adding acid. So H will go up. And of course, the other side will go down. If you're adding strong base, then the base side will go up and that side will go down. So that's a really easy way to remember it. Cameron, does that make sense? Please write back on the question answer if that was a good or not good. Hopefully I answered your question, Cameron. So tell me if that was a thumbs up or not. Okay, and I will look for your answer in a few minutes because the delay is a little behind. All right, so while I'm looking for Cameron's answer and whether that's okay. Now, what would happen if this was straight up water? So this is what the Maxi quiz would have. So let's pretend we have straight up HCl and water. Remember, HCl is strong acid. There's no two error. So you literally put pH of negative log of 0033. All right, remember, with strong acids, you stick it right in there. Okay, good. All right, so if I had no buffer at all, and I just put that straight up in there, what would happen? So log of 0.033, no buffer. Oh my gosh, you won't believe this. The pH is 1.48. Oh, you would die. The body only lasts in a pH of 6. Okay, so this is obviously not a body, but to go from a 4.6 down to a 1.5, you literally would have died in about 10 seconds if you had drank that without a buffer. Likewise, if you had put the NaOH in there, okay, then your POH, where's my red pen? Here. All right, so if we're doing the POH, all right, so POH is negative log of, again, it happens to be the same number. Now, the reason why I'm doing POH, because this is OH, okay? So if I'm adding in the amount of, again, pure water, this POH is 1.48. This is what everybody got wrong on the Maxi quiz, that your pH is then subtracted. So make sure when you do this problem, you realize what is it that you're sticking in there. If it's H's, go ahead and put it in there. But if you're sticking in OH's, then you're really solving for a POH. Then flip it. Don't subtract unless you're solving for OH. Okay. Any questions on that before I move on? So as you can see, this would have been a pH of, let's see, what's 14 minus 1.4? 12.52. Dang, people, that's basic. Woo! 12 pH is like Drano. So if you ever had like a pipe that was clogged and you had to pour the chemical in to like eat up the hair and the conditioner and the fat, that's a pH of 12. So you, in pure water, that little bit, that 0.01, that's like a penny. It's like a little crystal. That's enough to take the pH down to Drano level. But with a buffer, it only brought it down, what, 0.462 to 4.66. That's not bad. So buffers are powerful. Very, very good. All right. Now, the new stuff for today. So if you can, and for homework on Friday, I'd like for you to answer. So we answered number 5 and 6. So we just answered 5. What would happen if you added without buffer? Number 6, what would happen if you added with buffer? We just finished that. So 7 and 8 will be due on Friday. So if you guys can do that on your own, we're going to move on to the next worksheet. Okay. All right. Next worksheet is Henderson-Hasselbalch. Okay. Now, personally, I like to call this the Hasselhoff, and I'll show you a video in a little bit at the end. But this formula is really cool because it's a shortcut. And those of you who hate ice tables, you're going to love this. It's going to be great. Okay. Let me erase the board real quick. Let's get some space here. Now, any questions, go ahead and post them up there while I'm erasing, and I'll answer the questions as I come along, okay? Before I forget, Friday, we are working on our STEM lab, okay? You need to have your procedure done before you walk in. And when I mean procedure, I mean, how are you going to make your standard curve? So let me talk about that for a few minutes, because I want to make sure we don't lose any time on Friday because we're so behind. So on Friday, when you come in for lab, I need to know the procedure for the standard curve, okay? So if you don't remember, look up Beer's law, okay? Look up the procedure for Beer's law and go ahead and print that out and have it with you on Friday. Remember what you're doing is you're going to do suck out, right? So you have my stock solution of red dye 40, and you're going to suck out some and put it into your volumetric flask. Remember that? Okay. How much are you going to suck out? You're going to do this 4 more times. So what size containers you're going to have? Are you going to pull out 2 milliliters, 4, 6, 8? Are you going to do 1, 3, 5, 7? So how much are you going to pull out from each one to make your standard curve? And if you don't remember, the standard curve is then you have your 5 dots. Remember that? And then you graph it. And after you graph it, you get your y equals 36.7x plus 18. You know, you get that formula. Then you put your cough syrup in the machine. Then you put your jelly beans, your Play-Doh, whatever it is you're solving for, that goes in the machine. You get that number, and then that number gets stuck into here, okay? But you need to rock this in 30 minutes or less on Friday to be able to get done in time, okay? So make sure you know how to do the standard curve before you come in. Your lab report for this project is going to be a brochure. So if you go on the internet and look up trifold brochure, just something like this, this is what you're going to be handing out at your booth. Remember, it's April 21st, noon to 4. If you can't make it in time during that time, you need to talk to me. But this is going to be your lab report. So you need to make sure you have a minimum of 2 references, and the references have to be science journals. So yes, you got to get on Galileo. All right, but these 2 references, what are you going to be looking at? The history of red dye 40. Okay, where was it discovered? How was it made? What's the chemical formula? What is it, right? And what are the differences with red dye 40? Okay. So does red dye 40 cause cancer? You know, what are the issues? So please have that in part of your background. You're also going to put in your trifold, you're going to put in here your procedure, your hypothesis. So if you're doing cough syrup, your hypothesis is we think generic brands of cough syrup are better to give children than brand name ones. Okay, so whatever it is. So you need to talk about that in your brochure. So you need to start that because that thing is your report. Now, how many copies do you need? If you want to do black and white, I can make as many as you want, free. If you want to do color, I can do maximum 15 in color. I don't care which one it is, but if you like to, you know, kind of make it fast, you can do color. You'll just have to pay for any copies over 15. You have to do it on your own. The SST office can do 15 for you. Right? If you also need money in terms of buying your materials, like some people last year needed help with buying the popsicles, you know, there were a ton of money. I have a little bit of money for that too, but you need to let me know that ASAP. Okay. All right. So Cameron, then the email. Okay. So yeah, the worksheets that I would talk about were in the email I sent last night. So I'm sorry. Cameron, did you find it? Hopefully you found the worksheets. Okay. Okay, so that's for Friday. Make sure you come in with your procedures ready. All right, Henderson-Hasselbalch. Let's go to this wonderful equation. So if you could go back to Henderson-Hasselbalch, and it says here, I'm going to let you do number 1 on your own. It tells you, asks you which ones are buffers, okay? But number 2 is the formula. So let's read it together. The equation says pH equals pKa, okay, we have to think about what that is, plus a log. And what you're going to do is divide 2 numbers and then push the log button, all right? So I'm going to show you how that formula works with this last worksheet to show you it's totally faster, okay? Thank you, Cameron. Good. I'm glad you found it. All right, that's the last thing we'll work on. So remember this problem right here? Okay, remember that problem, the original problem, all right? So if you remember the ice table, you had C2H3O2, and if I remember correctly, you had O8 polarity of this guy, yes? After you divide it by 3 liters. And then with the leftover, remember that, the conjugate base, we had O6. Guys, remember that, okay? All right? Now, this is how you use the Henderson-Hasselbalch. Watch this. What's the pH? All right? Is pKa plus log. Now, it says conjugate base over acid. So just remember, bah, like a sheep. Bah, it's conjugate base over acid. It's a little different for base buffers. We'll talk about that in a class. But for an acid buffer, it's bah. So which one is the conjugate base? That one right there. So we're going to put that over here. O6. Where's the acid, the weak acid? Right here. O8. All right, so ladies and gentlemen, take your calculators because I know you have them next to you. You're going to take O6 divided by O8, then push the log button. Don't push the log button first. Now, if you're a parentheses king or queen and you're able to do the parentheses in there, okay. But just to be on the safe side, I always like to do them separate because, you know, fat fingers cost you points on the test. There we go, and your maxi quiz on buffers is next Friday during lunch, so it's a week from this Friday. Okay, so log of that. Okay, all right. So I have pH is pKa plus negative 0.1249. So hopefully you guys got that far. All right. Now, how do I do a pKa? Well, pH is negative log of an H. pOH is a negative log of an OH. So what do you think pKa might be? Oh, I don't know, maybe negative log of the Ka? All right, so look back at the problem. If you remember, the Ka was 1.8 times 10 to the negative 5. Huh. So pKa would be negative log of that number. Then you add on there this negative 1249. Let's put this all together. All right, so plus negative log of, oh my gosh, I don't know about you, oh my gosh, I got a pH of 4.62. Bam, that's exactly the same pH we got when we got the other worksheet. So if you don't like ice tables, you're like, ice me, baby, I am done with it. If it's only if it's a buffer, you can do this. And what's really cool is, last thing, and I'll let you guys go. Let's say a leprechaun came around, all right? La, 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 right? And you added the 0033 of base. Watch this. You can do it right up in here, too. You don't even have to do an ice table. So remember we added the 033 of the base? Well, then guess what? I can just change the numbers right here, and it's easy. So remember the top number is the base. So if I add base, then this number goes up to 0633. Remember that? And then this number would go down to 0767. Remember that? Okay? Boom. Divide that, and you'll get the right pH again. I love this equation, and you don't have to do ice table. How great is that? Okay. I'm going to see you guys Friday about 8:05, 8:10-ish, right, at lab. Again, don't forget to have your procedure done. Your homework's coming out tonight, and you'll have till Tuesday to finish it. This was really cool. I really like this. I know. Shortcut is freaking out. Don't you love shortcuts? I know. All right. I love y'all. Thank you for being here. And apparently some people already checked out. So, okay. Bye. Let's see. Cameron, yes. Dimitri got it. Josh thinks the shortcut is awesome. Winter got the right answer. Woohoo! All right. Woo-woo. Okay. So if you guys want to watch the video again to help you with your homework, you can. All right. I'm going to stop the broadcast if there's any other questions. And it's 11:15. I never want to ice again. All right. Although ice is, yeah. Cameron, I know. I knew you liked the shortcut as well. All right. Well, thank you so much for doing this. I'll see you guys Friday in lab. Okay. Don't forget goggles. Don't forget goggles, mandatory, and long pants and shoes. Okay. If I see any skin down here, I'm kicking you out of lab. All right. They're being very, very anal about that. Oh, I shouldn't say anal. Strict about it. Yeah, I know. This is an awesome class. We should do this more often, huh? Yay. Okay. Bye, guys.